part 2 of our series on chemical reactions and equations. In the last part, we understood what chemical reactions are, how to identify them, and how to write and balance chemical equations. You can find the link in description. In today's class, we'll go deeper into the different types of chemical reactions, the concept of oxidation and reduction, and the effects of oxidation in our daily life, corrosion and rancidity. So, let's begin. In a combination reaction, two or more reactants combine to form a single product. A combines with B and form AB. Examples: carbon combine with oxygen to form CO2G hydrogen, combines with oxygen to form water, calcium oxide, and water combine to produce calcium hydroxide. Such reactions are usually exothermic, they release heat. Opposite to combination is decomposition reaction. Here, a single compound breaks down into two or more simpler products. A B breaks down into two products. A and B energy is usually required: heat, electricity, or light. Types: thermal decomposition, heat, calcium carbonate. CaCO3 decomposes into calcium oxide, CaO, and carbon dioxide, CO2, when heated. Electrolytic decomposition, electricity. A single compound, water 2H2O, is broken down into its constituent elements: hydrogen gas 2H2 and oxygen gas O2. This process typically requires an input of energy, such as electrical energy in the case of electrolysis. Photolytic decomposition, light. This reaction shows the photolytic decomposition of silver chloride, AgCl, into solid silver, Ag, and chlorine gas Cl2 when exposed to light. And this is a decomposition reaction, specifically a photolysis, used in photography. In displacement reaction, a more reactive element displaces a less reactive one from its compound. A single displacement reaction where one element A replaces another element B within a compound BC to form a new compound AC and the displaced element B. Examples: iron Fe is more reactive than copper Cu and displaces it from its compound copper sulfate CuSO4 to form iron sulfate FeSO4. O4 and elemental copper Cu. Displacement reaction where a more reactive metal zinc displaces a less reactive metal copper from its compound copper sulfate to form zinc sulfate and elemental copper. In double displacement reaction, ions are exchanged between two compounds. In double displacement reaction, the positive ions called cations and negative ions called anions of two different compounds, AB and CD, exchange places, forming two new compounds, AD and CB types. Precipitation reaction forms insoluble solid, a double displacement reaction, and a precipitation reaction where aqueous solutions of barium chloride and sodium sulfate exchange ions, forming a solid insoluble precipitate of barium sulfate and an aqueous solution of sodium chloride. Neutralization reaction: acid plus base, salt plus water. The reaction between aqueous hydrochloric acid HCl and aqueous sodium hydroxide NaOH is a neutralization reaction where an acid and a base react to form a salt, sodium chloride, and water. This is also classified as a double displacement reaction, where the positive ions H plus from HCl and Na plus from NaOH switch partners with the negative ions chloride from hydrogen chloride and hydroxide from sodium hydroxide to form new products. Now comes a very important concept: redox reactions. Oxidation means addition of oxygen, removal of hydrogen, or loss of electrons. Reduction means removal of oxygen, addition of hydrogen, or gain of electrons. Since oxidation and reduction always occur together, the reactions are called redox reactions. Example: a redox reaction in which hydrogen gas reduces copper oxide to copper metal, while copper oxide is oxidized to water. Copper oxide loses oxygen to become elemental copper, and hydrogen gains oxygen to form water. Copper oxide is reduced to copper metal. Hydrogen is oxidized to water. Copper oxide acts as the oxidizing agent. Hydrogen acts as the reducing agent. So, friends, in this part 2, we studied the 5 types of reactions: combination, decomposition, displacement, double displacement, and redox. If you found this video helpful, don't forget to like, share, and subscribe for more science lessons. And in the comments, tell me which type of chemical reaction do you find most fascinating. In next video, we learn how oxidation affects us in real life through corrosion and rancidity. See you in the next video.